Can star develop into a planet? Professional astronomers view the stars as a component of a vast, extreme natural laboratory. Stars provide a testbed for hypotheses and observations on the behavior of matter that cannot be understood by on-ground observations, light years distant in the center of the cosmos. The Sun, our star, is not an exception. Halfway through its 10 billion-year existence, it will also vanish. As we talk about stars and their futures, a lot of research is still being done. Are stars all the same? Do they all share the same or what appears to be the same fate? What occurs to stars once they pass away? In this video, we'll talk about a fairly unusual fate that some stars experience. Can stars develop into planets? Let's talk more about stars and planets before we go on to this interesting topic. If you haven't already viewed our in-depth video about stars or how they die, be sure to do so to fully understand this subject. Let's review the planets, stars, and what happens to them. Prior to the space revolution, planets were little more than specks in the sky that, when viewed through a telescope, displayed hazy details. Planets are now considered to be true new worlds, complete with mountains, valleys, volcanoes, ring systems, and massive swarms of moons, thanks to meticulous space probe investigations. Depending on how far a planet is from a star, the temperature of its surface can change. When gases and minute particles combine, spinning under the influence of their own gravity, planets are formed around freshly formed stars. The big planets continue to collide, creating more debris that eventually forms new planets. On the other hand, stars are enormous balls formed of gas and dust, and the amount of gas used to produce them determines how different their surface temperatures can be. The Type O star category is the hottest, and the Type M star category is the coolest. A solar nebula, a huge cloud of gas and dust, is where stars are formed. They are created in great numbers and are first known as protostars. They later develop into a cluster of stars, such as the Tucane 47 globular cluster. Depending on a star's mass, its destiny changes. The term main sequence star refers to a class of stars that includes stars like the Sun. For billions of years, the core fusion reactions of these stars continue. As they near the conclusion of their existence, they gradually cool off and continue to grow to become giants and supergiants. They spend around 1 billion years in the gigantic phase. During this time, the star uses nuclear fusion to change helium into lithium, then beryllium, then iron through a series of processes. Main sequence stars have a dense iron core after using up all of their fuel. The star's gravity also becomes less powerful, making it impossible for the star to support its outermost layers. White dwarfs are not suitable candidates to be categorized as planets since they eventually lose their outer layers in supernova explosions and form a white dwarf star centered on the stellar remnants of the dead star. The primary pattern supernovae, which produce planetary objects like black holes, neutron stars, or white dwarfs, are the final result of stars with masses more than 1.4 times that of the Sun. These objects see no chance of becoming planets. The query is now raised. Can any star become a planet at any time during its life? We were unable to locate any evidence that this could happen at any point throughout the life of an ideal star. Or are there perhaps more categories for stars? Our questions have an easy solution, and it may be found in planetary nebulas, the star-forming regions. There is absolutely no potential of planet formation from main sequence stars. But there are other kinds of stars, or, perhaps more accurately, failed stars. The dark dwarf. Due to its failure to maintain a nuclear reaction, many people do not consider it to be a star. So what distinguishes the brown dwarfs? Brown dwarfs, can they live there? Not every protostar can develop into a star. Some protostars fail to initiate nuclear reactions, while others blast away during protostar creation or are devoured by other protostars. Now consider the scenario in which a huge protostar would not be sufficient in comparison to other stars. A protostar of this type couldn't produce enough gravitational field at its core to support nuclear fusion. Since it doesn't compete with other protostars to become a star, it simply remains what it is. The brown dwarf appears right here. Hydrogen cannot be fused by brown dwarfs. Deuterium, which is relatively scarce compared to the abundance of hydrogen in space, is the primary fusion reaction that sustains brown dwarfs. As a result, brown dwarfs cool down and run out of nuclear fuel early in their lifespan. Such a body would merely radiate all of its energy into space, slowly cooling over many billions of years and eventually becoming a dead stony mass. These objects are known as brown dwarfs or non-igniting stars in astronomy. The color of brown dwarfs isn't really brown. Infrared imaging shows them to be red because they produce very little light. Brown dwarfs are still large, enough for planets to be in orbit around them. As a result, planets orbit brown dwarfs in a manner similar to that of a star, giving the impression that several planets are revolving around a single large planet. The mass of a typical brown dwarf is 20 times that of Jupiter. Numerous academic publications on the finding of new stars and planets were published during the beginning of the 20th century. Professor Shiv S. Kumar of the University of Virginia foresaw the existence of brown dwarfs, or black stars as they are also known, in 1963. Based on calculations of the minimal mass a protostar needs to become a star, they made the prediction. But it wasn't until 1995 that astronomers were able to confirm the existence of brown dwarfs. Due to their extremely low light and infrared emissions, which were challenging to detect in the past, brown dwarfs are challenging to examine. As a result, they maintain their cool and stealth throughout their entire existence. Only roughly 4,000 brown dwarfs have been found so far. But let's not forget that the failed stars are the brown dwarfs. It follows that even the smallest brown dwarf ever found was twice as big as Jupiter. White dwarfs could still turn into planets, though, if certain conditions are met. In fact, every star in this universe that will one day become a white dwarf will first exist as a planet. So, don't be shocked when I tell that even our sun will eventually transform into a giant planet. We can still categorize it as a planet even if the gravity would still be so strong that it wouldn't be habitable for a living mechanism to thrive. Let's move into the far future. Our cosmos will enter a phase known as the degenerate period after a septillion years, or 10 billion trillion years. Light from one cosmic body could not reach another during this period because the cosmos would be expanding at a rate faster than the speed of light. The universe is expanding and will continue to do so, as we all know. We would all have been scattered throughout space by this point, isolated from other galaxies in the dark. By then, every star in the universe would have died and the most recent stars would have evolved into white dwarfs. Even white dwarfs would have undergone extreme cooling in space to the point that they could hardly continue to radiate light or heat, dying by evolving into brown dwarfs, massive planetary objects that emit very little to no heat. This question has several potential answers that are just waiting for further investigation and understanding. Given that we still have a long way to go, we could not know the answers to these questions at this time. Since the future of our universe is the most enigmatic of all, we might never even learn the answers to all of our questions.